All right, let's get down to business to defeat the Hun. So, 5-year-old boy is brought to a pediatrician due to recurrent skin infections, recurrent skin and fungal infections, and Staphylococcus aureus disease, and signs of inflammation. Neutrophil function test with impaired oxidative burst should all make us think of chronic granulomatous disease. So, in this disease, this kid's white blood cells, his neutrophils, should kill the bacteria using chemicals called reactive oxygenation species. They should just kill it with that. But you can't because you have a faulty enzyme, NADPH oxidase. That's the impaired oxidative burst. So some bacteria can make an enzyme called catalase. So I'm going to show you a little picture of that here. Boom. Catalase. Okay, so what does that do? It breaks down hydrogen peroxide, which is a chemical that could help the neutrophils, the white blood cells, kill the bacteria, even with the defect. But because the bacteria destroy hydrogen peroxide, catalase positive, the immune system can't fight them off, and it leads to repeated infections. So repeated infections, catalase positive, and we know this because Staph aureus is famously catalase positive. So our answer is going to be catalase. Coagulase, let's talk about that. Staph aureus. This helps Staph aureus hide, but it's not the main problem in our condition here. Staph aureus causes coagulase to turn fibrinogen into fibrin, which then causes a protective barrier around itself to avoid the immune system. It's like, hey, let's just hide here in this little fibrinous capsule Staph aureus. But here we are dealing with a recurrence infection, not evading phagocytosis, because you're having trouble killing the bacteria even after phagocytosis. That's the problem. And also, like Serratia, for instance, and Aspergillus does not produce coagulase, and so coagulase is not the main issue. So importantly, the second one, no coagulase. Okay. Lecithinase. So that's Clostridium perfringens, which is alpha toxin, and that would destroy the phospholipids of the cell and the cell membranes, leading to the tissue death. And that causes gas gangrene, but not the recurrent infections. So alpha toxin, if you have lecithinase, it'll destroy the phospholipids in the cell membranes, and that causes necrosis. So the gangrenous death. We hate that. LPS. Let's talk about that one. Triggers an immune response, but does not protect the bacteria. So LPS is part of the outer membrane of a gram-negative bacteria. And it acts as an endotoxin, which can trigger inflammation and fever. And it can make infections worse, but it doesn't actually resist the neutrophil killing. Polysaccharide capsule, that should make us think of Neisseria meningitidis. Just GD patients would have normal resistance to encapsulated bacteria like Streptococcus pneumoniae. So it's not the problem with engulfing because capsules protect bacteria by preventing them from being phagocytosed. So the final takeaway here, the most important thing, and you can look at these explanations if you'd like. This kiddo has CGT, defective NADPH oxidase, impairing the neutrophil-mediated killing of these pathogens. And so he's susceptible to catalase-positive organisms because catalase degrades hydrogen peroxide, and that prevents neutrophils from using it to kill the microbes. And so if you have a problem with your oxidative burst, you have this backup mechanism with hydrogen peroxide. It doesn't work because the catalase destroys it. Hopefully that's helpful. If it was, like and subscribe, especially because of this awesome little picture here. Woo! We'd love to see it.